Hi everyone, and welcome to another chemistry video. Today I'm going to be talking about ions and how to form neutral compounds. So I'm going to start off by talking about these trends on the periodic table because I feel like having a good foundation of the periodic table and understanding it is going to make this process a lot easier. So as you can see on this periodic table, I've gone ahead and labeled it with some of the predictable charges. And we can see that on the left side, groups 1 and 2 have predictable charges of 1 plus and 2 plus. If we look over on the right side, we can see, for example, group 17 has a predictable charge of 1 minus, and group 16 has a predictable charge of 2 minus. So what this is telling us is in order for an element to get to a full octet, it either has to gain electrons or it has to lose electrons. On the left side of the periodic table, when we take a look at those group 1 and 2 metals, we can see that they are very likely to lose electrons. And the reason for that is that their valence shell only has 1 or 2 electrons in it. And so it's a lot easier for them to lose those and get to a full octet in the next shell rather than having to gain like 7 more, for example, or 6 more in order to get to that full octet. So they will very readily give up those electrons. On the other hand, if we look at group 17, for example, that's at a 1 minus predictable charge, meaning that elements like fluorine and chlorine will want to gain an electron because they have 7 electrons in their valence shell. So they're only 1 away from a full octet. Or in group 16, they're only 2 away from a full octet. So it's much easier for those elements to gain electrons and then get to a full octet. A full octet is very comfortable for an element, and that is why in group 18, those noble gases are generally non-reactive because they are comfortable. They're like, we're at a full octet, we have nothing driving us towards chemical reactions because we're not trying to gain electrons, we're not trying to lose electrons, we are happy. So think about it like that. The group 18 elements are happy. Other elements want to be like group 18. They want to be comfortable. So because of that, they will combine with other atoms to form a neutral compound. I'm going to start with a simple example, and I'm going to show you a method called the cross and drop, which just makes it a lot easier to see how these neutral compounds are forming and to get that math correct as well. So let's say that we have aluminum and oxygen, and we want these two to form together in a ratio that allows them to have a neutral compound. What we want to do first is take a look at the periodic table. I want to find these elements on the periodic table, so I'm going to locate aluminum in group 13, and that is telling me that it has a 3 plus predictable charge, whereas oxygen is in group 16, and has a predictable charge of 2 minus. So I'm going to go ahead and write that down. Now, what I'm going to do is I'm going to draw these arrows in a cross, and I'm going to drop down that charge into the subscript of the element. So that gives me aluminum subscript 2, oxygen subscript 3. So that is telling me that in a neutral compound of aluminum oxide, we have 2 aluminums for every 3 oxygens, and that is going to even out to a net 0 charge. So if we actually write that math out, if we have a aluminum which is 3 plus charge and we have 2 of them, so 3 times 2 is going to be positive 6, whereas if we have 2 minus oxygen, we have oxygens with a 2 minus charge, times 3 oxygens, that's going to give us a minus 6 charge. And if we add up those charges, they are adding up to 0. So that's what we want. We want a neutral compound. All right, so let's do another example. I'm going to erase this to make more space. Okay, let's say you're taking an exam and the question says, write the formula for, we'll do calcium iodide. Write the formula for calcium iodide. All right. Now, there's that nomenclature for an ionic compound, right? Ionic is telling us that we have a metal, that's the calcium, plus a nonmetal, that's the iodine, right? Now notice that this nomenclature does not have any prefixes that tell us how many atoms there are in that neutral compound. So we don't have any mono, di, tri before the element name to tell us how many there are. This is because ionic compounds don't need those prefixes. They would be redundant because we can figure out how many there are based off of these predictable charges. So let us go ahead and we'll do the cross and drop method again to see this. All right, so if we have calcium, I'm going to write it up here on the right. So we have calcium and we have iodine. Calcium is going to be in group 2, and that means that we have a 2+ predictable charge. And then iodine is in group 17, that is a 1- predictable charge. So we're going to do cross and drop, and that gives us calcium subscript 1, although we don't write the 1 normally, so I'm just going to leave it as calcium, but we have 1 calcium, and then we have iodine subscript 2. Right, so for every 1 calcium, there are 2 iodines. That's going to give us neutrality. All right, so we have 2+ times 1 equals 2, and then we have 1- times 2 equals -2. We add those up, and they're equaling to 0. And that is our neutral compound. All right, now let's try something a little different. Let's do something a little bit more challenging now. Let me go through and delete again. All right. Let's say that the question is saying, write the formula for copper bromide, copper 1 bromide. So we can see that there is a Roman numeral here, all right? Now, the reason for that is some of these ionic compounds have to be written with Roman numerals. The reason is that they fall into a group, the metal will fall into a group that isn't so predictable. So in this case, we have copper in group 11. I'll circle it here. All right, so we're in group 11. That is not a very clear-cut predictable charge, meaning that it can change depending on what it's combining with. So let's write this out, okay, because this Roman numeral is actually telling us something. So if we have, again, I'm going to go up here on the right, we have copper, and we have bromine. Okay, so we know that bromine is 1- based off of where it is in the periodic table. And then copper, this Roman numeral right here is telling us that this copper is going to be charged +1, right? So that's what it's trying to communicate to us. So now I know what my ratio is going to be because, again, I need a neutral compound. If I do cross and drop, all that's telling me is I just need 1 of each, right? So that copper bromide is just going to be a 1-to-1 ratio. So hopefully this was a good review of predictable charges, forming neutral compounds, and also some nomenclature. Nomenclature is very important in chemistry because a lot of times questions are written by name, and you have to know what that name is telling you and be able to interpret that in terms of how many elements are present and whether it's ionic, whether it is molecular. Names tell us a lot of important things. If you have any questions, feel free to leave them in the comments and I will respond. Thanks, everyone.